Welcome back. Now, our player-controlled bot pawn and our BP bot actor both shoot blaster beams. And now those blaster beams belong to two different classes, which both inherit from one parent class called BP blaster beam. So these two child classes inherit the behaviors that BP blaster beam has, namely it's moved by a projectile movement component, and it has an event bound to onComponent hit for the beam mesh. An onComponent hit simply calls handle on hit. And in handle on hit, we have a couple things happening. For one, we spawn a Niagara system, and then we check if the actor that was hit is the target pawn. If so, we call quit game, and if not, we destroy the blaster beam itself. Now, this is not the best approach to handling a hit event. Why? Because, well, now we have a bot pawn that can fire blaster beams, and when we hit one of these bots, well, we'd like to do something. Maybe we'd like to blow it up. And in that case, this target pawn variable isn't really going to work. Remember, target pawn is set on the blaster beam when it's spawned by the BP bot. In BP bot's spawn blaster beam function, it sets the target pawn. Each BP bot finds a target pawn at the beginning of the game, and then once it spawns a blaster beam, it sets that target pawn. Well, when our player-controlled bot pawn fires the rifle, it does not set that target pawn variable. So our blaster beams need to be more versatile. They need to be able to cause some functionality to happen when hitting something without really needing to know or care what was hit. And for this, we can use a very important concept called interfaces. And interfaces are a little confusing to newcomers, and they're perhaps best explained by showing rather than telling. So let's make a blueprint interface right now. So in our blueprints folder, I'm going to make a new folder called interfaces. And in interfaces, we're going to make our first blueprint interface. So we can do that by right-clicking, going to blueprint, and selecting blueprint interface. Now the tooltip says a blueprint interface is a collection of one or more functions, name only, no implementation, that can be added to other blueprints. These other blueprints are then expected to implement the functions of the blueprint interface in a unique manner. Okay, so I know that sounded like a whole lot of confusion, but keep these two phrases in mind. Name only, no implementation. So let's create our blueprint interface, and we typically prefix these with BPI, short for blueprint interface. And I'm going to call this damageable, damageable. And anything that I want to be damageable, in other words, if we hit it with a blaster beam, we want to cause damage to it, it can implement this interface. So what is an interface? Well, if we double click it, we can see exactly what it is. Just like the tooltip said, it's a collection of functions, but it's a collection of function names, really. No implementation. What does that mean? Well, there's no functionality connected to these function names. That's why the event graph is grayed out. We cannot add nodes to our functions. And as soon as we create one, it has an automatically added function. Now, for BPI damageable, I want a function that we can call when something gets hurt, when something takes damage. So we're going to call this function getHurt. And these functions can have inputs and even outputs if we want. For instance, if we call getHurt on something, we can hurt that object with a specified numerical amount of damage. Let's say we have an amount of damage that our blaster beam wants to deal to the actor it hits. Well, this interface function getHurt can take in an input, let's call it damage, and we can change its type to float. It could easily be an integer. That's really the preference of your game. I'm going to leave it at float. And we now have this getHurt function that takes in a float called damage. Now, in the interface here, we cannot add functionality. It's grayed out. We can't just say take health and subtract from health. There is no health. There is no owning actor here. That's not what the interface is for. Now, you might think that this makes this interface quite useless. What good is a function that does nothing? Well, this is actually a strength. You see, when our blaster beam hits something, it can see if that hit actor has this interface. If so, it can call this getHurt function. And any particular actor class that implements this interface can have its own custom implementation of getHurt. For instance, let's go to our bot pawn. And let's say that we'd like our bot pawn to have this interface. We say that we'd like it to implement this interface. We do so by going to class settings. And in class settings, there's an interfaces group. And under implemented interfaces, we have a drop-down. We can click add and search for our interface, BPI damageable. If we select that, now under the drop-down, we can see that this particular actor called bot pawn is implementing BPI damageable. That means it inherits the functions in that interface. Now, there's only one. If we go back to BPI damageable, there's only one function, getHurt. It takes a float called damage. Now that bot pawn implements this interface, it has a getHurt function. And we can find it under My Blueprint, and we click on compile. If we scroll down, we should see functions that belong to interfaces implemented by this actor. We don't see any because we have to go back to BPI damageable and click on compile. Now that we've compiled this change, the change of adding getHurt, we can go back to bot pawn, and now we have a new interfaces section with a drop-down, and there's that getHurt function. Now, if we double click on it, we all of a sudden have an event getHurt in our event graph. And we can decide what happens whenever getHurt gets called on this bot pawn. For instance, this bot pawn may have health. And when we get hurt, we can subtract this damage amount from our health. Why don't we do that? Let's click add to add a new variable. We can call it health. We can change its type from Boolean to float, compile, and give it a default value such as 100. And when event getHurt gets called, we can set health equal to itself minus damage. So I can get a subtract node and subtract damage from health and take that result and set my health variable. Now, just to prove that it's happening, I'm going to use a print string node and get an append string node and say took damage health colon space, and I'll print the value of my current health after taking damage. So this will go into my print string node like so. So that's what can happen now when our bot pawn gets hit. Now, how do we call this function? Well, that's pretty simple. I'm going to compile and save and go back to Blaster Beam. And as soon as handle on hit is called, I'm no longer going to check if the hit actor is equal to target pawn. I'm going to move those out of the way. Instead, I'm going to take the hit actor and check to see if it implements the damageable interface. To do that, I take the hit actor, and by the way, remember this is an input parameter to handle on hit, which is called from on component hit event, which is bound to on component hit for the beam mesh, okay? Just so we're on the same page. This hit actor is available as a node here in the function. So I'm going to take this hit actor, which by the way is an object reference, and we can check to see if the hit actor implements any given interface with the function does object implement interface. Now to check to see if the hit actor implements our BPI damageable interface, we have to find that interface from the dropdown. We can search for BPI and select BPI damageable. If this actor implements this interface, the return value will be true. So now, instead of checking to see if the hit actor is equal to the target pawn on the blaster beam, we're now checking to see if it's implementing the BPI damageable interface? And if it is, we can call getHurt, the interface function. We can do that by taking our hit actor, dragging off, and searching for getHurt. Notice it says message. It's an interface function call. Interface function calls say message, and the pop-up says this does nothing if the target does not implement the required interface. So really, that branch that we did just before calling hit actor wasn't absolutely necessary, but it does prevent us from calling getHurt on anything that doesn't implement the interface. So let's call that, and we can just hook that straight up. Now, how much damage do we want to cause? Well, we could have a damage variable on the blaster beam. Let's just add a new variable called damage. We can change its type to float, compile, and give it a default value like 10, and we can hook in damage for the getHurt function. So now when blaster beam hits anything that implements the interface, it's going to call getHurt on it. Now, so far, the only thing that implements the interface is the bot pawn, and this is what it does. It subtracts from its health and prints a string now. So if we test this out by getting hit by some of these blaster beams, we should see the results. And there we go. Now, notice our blaster beams are no longer destroying themselves. And that's because, well, we're no longer calling destroy actor. We're just calling getHurt, and that's it. So we can call destroy actor. I'm going to take that destroy actor node and call it after getHurt. But what if we hit something that's not implementing this interface, like a wall or the floor? Well, we still want to destroy the blaster beam in that case too. So we need to hook up the false case from our branch up to destroy actor as well. So now that we're destroying the actor, let's play test again. And there we go, the beams are destroying themselves. So now we have health on our bot pawn. And we can do things like end the game when health reaches 0, for instance. All we'd have to do is get our health, check to see if it's less than or equal to 0, to take care of the case where we've overshot and went straight from a positive number to a negative number. We can check that, and if health is less than or equal to 0, then we can call quit game and let the bot pawn itself handle quitting the game once its own health has reached 0. So now we can play test, and we can see if the game ends after getting hit enough times, and sure enough, it does. So now when our blaster beam hits something that implements the interface, it calls getHurt on it. So far, only our bot pawn implements the interface. But here's the beauty of interfaces. We can go into our BP bot and implement the interface here in a different way. We do so by going to class settings and implementing the interface here. We click add and search for BPI damageable. And now our BP bot actor has BPI damageable, which means if we look in interfaces, it has a getHurt function, and we can double click it and implement it any way we want. For instance, we can blow up our bot. Now, to blow up the bot, it sure would be nice if I had some visual effects and sounds to make my bot blow up. Well, it just so happens that we have those in our collision tests level. Remember our collision test level when we checked out the different types of collisions and methods of movement? Well, I'm going to open that project and migrate a couple of assets over. So here I am back in my collision tests project. And in this project, if I go to global and effects, in projectiles, there's a fire explosion folder, and here's a fire explosion Niagara system. Here's what it looks like. I'd like to use that. I'd also like to use a fire explosion sound under global sounds explode. And here's a sound effect. It's a meta sound called SFX Firebolt Impact. I'd like that as well. So what I'm going to do is take my effects folder and just migrate the whole thing over. I'm going to right click on it, go to migrate. It's going to show me all the assets that will be migrated. Click OK. And I need to find my BadBot project and select the content folder. As soon as I select the folder, then I have those assets migrated. So that's the visual effects. And for the sounds, I'm just going to migrate the sounds folder. I'm going to choose migrate, click OK, and migrate it to my BadBot content folder. And now it's in that project. So I'm done with this one. I can close it. And now I have a global folder here. And in global, I have effects with my fire explosion here. And also I have my sounds folder with explode. And if you don't like that global folder, you can move these into the assets folder if you like to do that. I can take effects, move to assets, click move here. And I can take sounds, move these to assets, click move here. And now I don't need my global folder. I can delete it. So now that I have these assets, I'd like to spawn a system when my BP bot gets hurt. So I'm going to use spawn system at location. And for the system, I'm going to find fire explosion. For location, I'm going to use get actor location. And in addition to this, I'd like to play a sound at location. And for the sound, I'm going to choose SFX Firebolt Impact. And I'm going to use get actor location for this as well, like so. And after I've played these effects, I can go ahead and call destroy actor. So we have another implementation of get hurt on our BP bot, and this is drastically different than our implementation of get hurt on BotPawn. But here's the beauty of it. Back here in Blaster Beam, all I care about is if that hit actor implements the interface, and then I call get hurt, no matter what the hit actor is. Blaster Beam doesn't have to know or care what it's hitting. It just calls an interface function. Every actor that implements this interface can implement get hurt differently, and Blaster Beam doesn't have to call different things depending on the situation, like we were doing before. We can go ahead and delete those nodes, and we can play test this by trying to shoot at one of our drones. And there we go. We've blown up that drone. It was a little hard because we kind of couldn't see it. Our own mesh was in the way. But as soon as we get a hit, then we blow it up. Awesome. All right. So we now have covered a very important topic, the topic of interfaces. Interfaces allow us to have versatile, flexible code. Code that does not require a bunch of branches, checking to see if we hit this thing, do this. Otherwise, if we hit that thing, do that. We don't care what we hit. As long as it implements an interface, we can simply call get hurt. And as I mentioned, checking the interface is optional. We don't even have to have a branch. We can remove this branch, and we can simply call get hurt without even worrying if that hit actor implements the interface or not. Because get hurt will do nothing if it hits something that does not implement the interface, such as the floor. Let's test that out. Okay, looks like our blaster beams are passing straight through the floor. So let's debug that issue. We need to check out our player blaster beam, find its beam mesh, look at its collision presets, and see that it's blocking world static and ignoring world dynamic. And if we select our floor and select its static mesh component, we can see that its object type is world dynamic. But that's okay. Our floor is not actually moving. It's not really dynamic, is it? So we can change it to world static. Instead of using block all dynamic, we can use block all. And in that case, the floor will be a world static object type. And then we can check to see if we get those hit events. And we do. We could see those particles when our beams hit the floor. Excellent. Now we can see that we get hit and we take damage. And if the enemy gets hit, well, hopefully I can get a hit. There we go. Blew it up. Excellent. All right. Excellent job. And one of the next things we're going to do is make it a little bit easier to shoot our rifles because our mesh is right in the center of the screen and we can't really see what we're shooting at. Makes it kind of hard. So in the next video, we'll learn how to make things a little bit easier and a little more fun. Great job. I'll see you soon.